Discuss ta about sa multicollinearity. Sakto pa. What is multicollinearity? This occurs when two or more independent variables are highly correlated with one another in a regression model. So, magkuan ko o kuan. This ang gapasabot ani kay ang kanang independent variable bitaw kay pwede siya ma-predict sa usa ka another gyapon nga independent variable. Di ba kay usually atong kakakuan kay ang independent variable kay gina-predict siya sa dependent variable, pero sa kani siya ang multicollinearity kay ang independent variable kay pwede siya ma-predict sa another independent variable in a regression model. So magkuantag example kaning height or weight, household income and water consumption, or kanang study time, then leisure time, or uban pangapan. So, magkuanta og kaan another example nga kanang ma-apply nato in real life nga scenario. Paano to si Omar? Si Omar kay ganahan kayo magkuan tan-og salida. While gakaon og chichirya. So the more nga magtan-aw siya salida, the more pud nga kuan ganahan siya mukaon og chichirya, the more nga malipay siya. So if ma-quantify nato ang kalipayon ni Omar o ma-measure nato yung kalipayon while busy siya og kuan kanang buhat sa mga favorite activity niya, makuan ka ninyo kanang may bawan kaya ninyo if sa iyahang greater impact sa iyahang happiness, like ma-predict kaya ninyo unsa gid iyahang kuan kanang unsay impact sa iyang kan nga makapahappy siya ayo. If may bawan ninyo nga the more nga mo if ga-increase ang iyahang happiness tungod kay ga tan-aw siya sa salida niya, ga-increase po diyang happiness kay tan-aw siya gakaon siya chichirya, may bawaan ba ninyo, ma-measure ba ninyo or ma-predict ba ninyo kung asa gyud sa duha ang iyahang kuan nga ma-identify ninyo nga kani siya nga butang kay nakapa-impact jud siyang happiness? Do you think ma-kuan ninyo, ma-identify ninyo, ma-determine ninyo siya?
Kuan dili.
Lisod siya, di ba? Kay kuan good kanang balance good siya. Let's say balance siya nga kuan nga level, di ba Omar? So kuan siya makana to nga lisod siya i-determine kay the moment nga i-try na to measure ang happiness ni Omar gikan sa pagkaon niya sa chichirya o sa tan-aw niya sa salida, kay kuan dungan siya, so dili gyud nato siya ma-identify diretso. So kaning pagkaon niya sa chichirya o pag tan-aw niya sa kuan kay parehas siya, like highly correlated siya to each other nga case. So parehas sila nga kuan, like balance sila. So we cannot individually determine the impact of the individual activities on his happiness. And that is the explanation or example of a multicollinearity problem. So, multicollinearity can be a problem in a regression model because we would not be able to distinguish between the individual effects of the independent variable and the dependent variable. May man to kung dependent variable o independent variable kay may bawaan man din nato kay ma-use man nato ang kuan dependent variable para ma-predict nato sa ato ang data mining if na-observe ninyo na. Pero kani kay lisod gyud siya kay sila man duha balance man siya nga independent variable. So, pagkan sa correlations versus regression. So in correlation, it represents the relationship between two variables. However, in the regression nga kuan pod kay mag-represent siya og two or more variables. Now, in correlation, again, shows that two variables move together, no matter in which direction. Ang sa regression, it shows cause and effect. One variable is affected by the other. Then, sa correlation, na kay symmetrical ang iyahang two variables, and then the other one is one way. There is always one variable that is causally dependent. Then, sa correlation again is a single point per number, and in regression, a line or into 2D space. naikikuan si sa ano na equation mag-run. Pero wala lang kay dili ka function ako. For a while lang ha. Okay. So, muna gihatag nga formula di bali. Okay. So, y is equals to a0 ay ao ay a0 or ao plus a1 times x1 plus a2 plus x2. So, kaning kuan, a1 o a2, kay mo ni siya ang ato ang kuan. Let's say, atong independent variable. So, or independent variable and paano siya? Identical or ni silang duha, parehas or ni sila. So, we want to set up a simple linear regression. So, kani siya nga kanhimuon tani siya og linear regression. So, what we will going to do is, ang kaning y, i-transpose na to ang x1 sa y. So, yan na, kuha na to na siya. So, ang y, mahimo na siyang x1. So, ang mahitabo kay, gusto man nato nga i-predict ang x1 kay, di ba? Mumni itong kuan, independent variable and another independent variable. So, we want to predict our first independent variable, which is the x1. So pag-predict na to ana kay kanang ang di ba kay gi-transpose man nato siya sa y. So ang x1 na din karon mahimo na siya og dependent variable. So again, from independent variable dari mahimo na siya dayon og dependent variable dari. So mahitabo na din sa formula is x1 is equals to a2 times a2 which is kani times x2 plus kani ding a0. Pwede na siya dari gibutang ra diya, sorry kayo. So once nga ma-predict na ni natong x1, so sa pagkuha na nato, calculate na nato ani, ma-predict na nato ang x1 kay dili na nato kailangan ang x1 na dayon. Kay na-predict naman nato siya, so okay na ni siya. So ang mahitabo din ana, ang kaning magong tanan variables kay wala pa man ni nato nakuha. So kailangan pag nato ni siya i-predict. So mahitabo ana kay kanina sa dang x2, mupuli na sa siya sa x1. Kay kailangan magid nato siya i-predict tanan ana. So muna inya na siya nga equation. So pag kumana to dari, pag nanatay kuan answer ani di bali sa usa ka kuan equation di bali ay nanatay problem ana tapos na solve na nato ang x1 or ang first nato nga independent variable diri na punta sa x2. So same ra gyapon siya ang formula niya. So ang x2 oy mahimong dependent variable and then may kuan na din ta kani siya mahimo na din siyang a1 times x1 which is kaning kaganiha dari plus a0. So yan na siya. If kuan na siya, usually magod kay dili ra na siya duha ka variable sa daghan na siya na daghan kuan na siya kanang continue. Daghan na siya nga. Depende sa table or sa kuan sa database nga ginanhatag. So puli-puli na din na sila. So nagets ninyo siya ang kuan ang equation niya, ang process niya. Nagets ninyo.
Yes, ma'am. Nagets mo, ma'am.
Basta kay kaning once nga mabutang na to sa dependent or ikuha na to ipuli na to sa y si variable, independent variable, so may mo na siya og dependent variable. Gamiton na din nato siya para ma-predict na to ang kuan. Gamiton na to ang naadanhi kani sila dari para ma-predict na to ang kaning naa sa ato ang dependent variable. So once nga makuha na nato, dari na sa ta sa another nga independent variable, i-puli na sa nato dito sa pan. So, yan na siya conclusion. So, hopefully, nag-gets ninyo na siya, guys. And more na siya ang ako ang report for this. Or wala. Dili ka function akong mouse. Wait lang ha. Okay. Dili ka function akong mouse. Okay. Okay, guys. Na. So, next, guys, si Kuan na dayon. Ay, wala pa may pangutana sa katong previous nga Kuan. Nakasabot pa mo unsay meaning gyud sa multicollinearity. Sige to. Collinearity. Katong example na ko. Agets mo?
Oh, okay, Reyes.
Okay. Sige. So, Jeff, ikaw na sunod, Jeff Cantre. Thank you. Ikaw man ang kuan. Ikaw ang sunod.
Oh,
Duha
sunod.
man akong gikan. 1 ug 2 man ta ko ah.
Ano ito tayo, ma'am?
Iyahang kuan difference sa regression at sa multicollinearity ay sa collinearity and then sa kuan dayon sa katong equation dayon nga gipakita
Equation.
nako. So siya akong gikan. Ikaw na dayon.
Okay. Kande. Okay. So, upon knowing the meaning of multicollinearity, let's move on with the causes of multicollinearity. So, the following are the reasons that might occur due to the causes of multicollinearity. So, the first one, it exists or it could exist because of the problems in the data set at the time of creation. These problems could be because of poorly designed experiments, highly observational data, or the inability to manipulate the data. So this is known as data-related multicollinearity. Let's take an example when determining the electricity consumption of a household from the household income and the number of electrical appliances. We know that the number of electrical appliances in a household will also increase the household income. However, this cannot be removed from the data set because it is already appear na sa data set. So kanila mga instances is muna ito ginatawag na data-related multicollinearity. So the next is the multicollinearity could also occur when new variables are created which are dependent on other variables. So basically, when we do the data processing of future engineering to make the new futures from the existing futures, this is known as structure-related multicollinearity. So let's take an example of BMI. The BMI, when we want to create a variable BMI, we need to calculate its height and weight, which would include redundant information in the model because BMI is dependent on the height and weight itself. So next is when there are identical variables in the data set. So let's take for example, including the height of a person in kilograms and another for weight in grams or some other units. So when we have our data set, dapat isa lang yun siya ka-unit yung gamiton. Like for example, ang 1,000 grams is equal to 1 kg. So why not make it 2 kg lang tanan? Diba? Para di kaya na to ang kaning multicollinearity. Next is when we want to encode the categorical features to numerical features for applying the machine learning algorithms, since ML algorithms only understand numbers and not text. So in this task, we use the concept of the dummy variable, or known as dummy variable trap. So let's take for example, we have a data set that contains the status of marriage variable with 2 unique values. We have married and single. And when creating dummy variables for both of them, it would include redundant information. So instead of making a variable for married and single itself by text, then we can make it to 0 and 1 for married, or 0 then single to 1. Since ang ML algorithms kay ang iyang masabtan is numbers, dili as text. So ang last one is the insufficient data in some cases can also cause multicollinearity problems. Wala na may pangutana?
Wala, Jeff.
Wala naman. Sada kay mga Windows 11.
Sana yung Windows 11, Jeff, may helicopter.
So I think kung ano ko sa next.
Sunod kay silang kuan na dayon. Jonzee! Helicopter.
Ako na. Mag-discuss ko sa testing for multicollinearity with variance inflation factors or VIF. You'll be well on your way to assessing whether you need to remedy multicollinearity if you can determine which variables are affected by it and the degree of the association. You can measure multicollinearity in your regression model using a simple test. The variance inflation factor or VIF determines the strength of the association between independent variables. VIF is a measure of the amount of multicollinearity in a set of multiple regression variables. The variance or the VIF is the VIF for regression model variable is equal to the ratio of the overall model variance to the variance of a model that includes only the single independent variable. Dataset determining the salary of a person in a company based on the following features. Sa gender is 0 sa babae, then 1 sa lalaki. Age, years of service, years spent working in the company, and educational level, 0 for no formal education, 1 for undergraduation, and 2 for post-graduation. Si Amiel din ang mag-continue sa next discussion sa continuation about ani testing for multicollinearity with variance inflation factors. Amiel, ikaw na Amiel.
Testing for multicollinearity with variance inflation factors or the VIF. VIF determines the strength of the correlation between the independent variables. It is predicted by taking a variable and regressing it against every other variable. VIF score of an independent variable represents how well the variable is explained by other independent variables. R2 value is determined to find out how well an independent variable is described by the other independent variables. A high value of R2 means that the variable is highly correlated with the other variables. This is captured by the VIF, which is denoted below. So it is denoted as 1 over 1 minus R2. VIF starts at 1 and has no upper limit. VIF equals 1 means no correlation between the independent variable and the other variables. VIF exceeding 50 or 10 indicates high multicollinearity between this independent variable and the others. We can see here that the age and years of service have high VIF value, meaning they can be predicted by other independent variables in the dataset. Although correlation matrix and scatter plots can also be used to find multicollinearity, their findings only show the bivariate relationship between the independent variables. VIF is preferred as it can show the correlation of a variable with a group of other variables.
Hindi ko mag-ask. Ang kato bitang, when computing VIF bitaw, dito na to may bawaan if there is high multicollinearity sa tuwang variables, sakto ba?
Ay, when na dito.
Hindi ba, when makapag nga na bitaw, kung taas atong VIF, mo ba na siya atong pinaka-basis if na ay multicollinearity sa tuwang variables?
Oh,
Sakto? Tumuna ko
oh,
naman kay
ma'am.
Amiel. Ano lang?
Oh,
Salamat.
mo na siya, ma'am.
So, fixing multicollinearity. Once you've determined that there's an issue with multicollinearity in your model, there are several different ways that you can go about trying to fix it so that you can create an accurate regression model. These are the ways to make it possible. First is obtain more data. The more data you obtain for your model, the more precise the measurements can be and less variance there will be. This is one of the more obvious solutions to multicollinearity. And also removing a variable. Removing a variable can make your model less representative. However, it can sometimes be the only solution to removing and avoiding multicollinearity altogether.
Next is create a standard set of independent variables. Utilize a ridge regression or a partial square regression in conjunction with your model. If all else fails or you decide it's not worth it to do any additional work on the model, do nothing. Even by not changing a model where you know multicollinearity exists, it still may not affect the efficiency of taking the data from the existing model. That's it, guys. Thank you.
Good, good day, everyone. I'm Prince Dadubo, and I'm here to discuss about the additional concepts to review. And one of them is regression analysis, where it is one of the most widely used methods for predictions. And regression analysis is a set of statistical methods used for the estimation of relationships between a dependent variable and one or more independent variables. It can be utilized to assess the strength of the relationship between variables and for modeling the future relationships between them. In regression analysis, includes several variations such as linear regression is probably the most fundamental machine learning method out there and starting point for the advanced analytical learning of every aspiring data scientist. That in linear regression in in regression analysis is a linear approximation of a causal relationship between two or more variables. As we know, regression models are highly variable as they are one of the most common ways to make inferences and predictions. Apart from this, regression analysis is also employed to determine and assess factors that affect a certain outcome in a meaningful way. So, as many of other statistical techniques, regression models help us make predictions about population based on simple data and on analysis on linear regression, similar to other exploratory data analysis techniques, has the potential to yield both theoretical and practical benefits. And now on next reporter.
Good day, everyone. I'm gonna report about the ordinary least squares. Ordinary least square, one of the most used approaches for estimating the linear regression equation is the ordinary least square or OLS. However, because of its simplicity, it cannot always be used. As a result, all OLS regression assumptions must be met before this method of estimation may be used. By minimizing the sum of the squared residual ordinary least squares, also known as linear least squares, the total of the squared discrepancies between the observed and fitted values is minimized using this method, which create a line through the data points. So, how would you define a reasonable estimate? The estimate should tend to be right on target. They should not be systematically too high or too low. In other words, they should be unbiased or correct on average. Recognizing that estimates are almost never exactly correct, you want to minimize the discrepancy between the estimate value and actual value. Large differences are bad. So the assumption of a ordinary least squares regression. First is the individuals' observations are independent. Second, the variance is homogeneous. Levin's test is proposed by XLS stats to test the equality of the error variance. Third, residual follow a normal distribution. XLS stats offer several methods to test normality of residuals. So the linearity, the specified model must represent a linear relationship. No endogeneity, the independent variable shouldn't be correlated with the error terms. Normality and homoceneity, the variance of error should be consistent across observations. No autocorrelation. No identifiable relationship should exist between the values of the error terms. No multicollinearity. No predictor variable should be perfectly or almost perfectly explained by the other predictors. Assumption of linear regression. First is the independence of observations, no hidden or missing variables, linear relationship, normality of residuals, no little multicollinearity, homoscedasticity. All independent variables are uncorrelated with the error terms. And lastly is the observation of the error terms are uncorrelated with each other. That's all for me. Thank you.